Standard 11 Chemistry, Unit 4, Chemical Bondings and Molecular Structure, Part 15. Today we are going to learn about hybridization. In the last lecture we had already discussed about the geometrical shape of the molecule. Geometrical shape of the molecule like methane, and its shape is tetrahedral shape. Ammonia molecule has also tetrahedral shape. Water molecule is bent shape. So to explain the geometrical shape of the molecule, Louis Pauling introduced the concept of hybridization. Louis Pauling introduced the concept of hybridization. Now let's see about what is hybridization. As we have already discussed, the orbitals like S, P, D and F orbitals and their shape. Here the atomic orbitals are combined. Atomic orbitals are combined to form a new set of equivalent orbitals, and this is known as hybrid orbitals. For example, here S orbital in its spherical shape and P orbital which is in dumbbell shape. So here the intermixing of the orbital and the new set of equivalent orbital is known as hybrid orbitals, and the phenomena is called hybridization. Here the atomic orbitals combine to form a new set of equivalent orbitals known as hybrid orbitals. And the phenomena is known as hybridization. Suppose, for example, here if S orbital and the P orbitals are intermixing, it forms sp type hybridization. Okay. Suppose S type of orbital and two P type orbital are hybridized, and it is called sp2 hybridization. Or S orbital and the three P orbitals are intermixing, and the new set of the equivalent orbitals it is sp3 hybridization. Okay, so this simple concept about the hybridization. Atomic orbitals recombine into form a new set of the equivalent orbital, and it is called hybrid orbitals, and the phenomena is called hybridization. Hybridization like sp hybridization, sp2 hybridization, sp3 hybridization, etc. Or in another word, hybridization, it means the process of intermixing of orbital of slightly different their energies, slightly different energies, so as to redistribute their energy, so as to redistribute their energy. Here suppose s orbital and the p orbitals are intermixing, so they distribute their energies and and resulting in the formation of new set of orbital is here. Suppose s and p orbitals are intermixing, new set of sp orbital is formed, and the phenomena is called hybridization. Okay, so new set of orbitals of equivalent energy and shape. Now the characteristics of hybridization. The characteristics are the orbitals with equal or less energy difference overlap with each other. That means here the orbitals like s and s orbitals, they have equal energy, or while p orbitals and the s orbitals are different in energies, so they overlap with each other. Second, the number of hybrid orbitals produced is equal to the number of overlapped atomic orbital. That means here suppose one s and one p orbital are hybridized, it is called sp hybridization. Third, shape, size and the energy of hybrid orbitals are same or is same. Second, there are two types of geometry created due to hybridization. One is regular geometry and second is irregular geometry. Regular geometry, that means each of orbitals there are bonded pair. In irregular geometry, each orbitals there are bonded or lone pair. Here mainly 8 types of hybridization. Number 1, sp hybridization means s orbital plus p orbitals. Same as here for sp2, one s and two p orbitals, p plus p. Here sp3, s orbital and 3 p orbital. sp3d, that means here one s orbital, 3 p orbital and 1 d orbital. sp3d2, that means one s, 3 p and 2 d orbitals. sp3d3, that means one s, 3 p and 3 d orbitals are hybridized, and it forms sp3d3 hybridization. dsp2, here d, one d orbital, one s and two p orbitals are hybridized, and it forms dsp2 hybridization. And dsp3, one d, one s and three p orbitals are hybridized, and it forms dsp3 hybridization. So mainly here we discuss about sp, sp3 and sp3 hybridization, and the hybridization involving d orbitals like sp3d, sp3d2, sp3d3, dsp2 and dsp3. And the very most important table for the examination, hybridization is sp type hybridization, and the shape is linear and the bond angle is 180 degree. For example, in BeCl2 and in ethine molecule, it is ethine C2H2 ethine molecule, sp type hybridization, sp2 hybridization, and its shape is planar triangle and the bond angle is 120 degree. For example, boron trifluoride and C2H4, it is ethene. The example is very most important. sp3 hybridization, the shape of the molecule is tetrahedral shape and their bond angle is 109 degree 28 minute. For example, methane, ammonia, water molecule, or here C2H6, it is ethane molecule. sp3 sp3d, their shape is trigonal bipyramidal, 90 degree and 20 degree. Most important here, the example is very most important for the competitive examination also. PCl5 and PF5. PCl5, phosphorus pentachloride, and phosphorus pentafluorine. Next is sp3d2 and their shape is octahedral shape, bond angle 90 degree, SF6 sulfur hexafluoride and this chromium hexafluoride 3 minus. sp3d3 pentagonal bipyramidal shape, 90 degree and 72 degree, IF7. And the last is dsp2 type hybridization. Its shape is square planar 90 degree and NiCN4 2 minus. And D2sp3, which has also octahedral shape, and the example is CONH3 twice 6 3 plus. This is the concept about the hybridization and their shape. example is most important. Now method to determine the hybridization is most important for the competitive examination and the MCQ. How can you determine which type of hybridization is takes place, like SP, SP2, SP3, SP3D, SP3D2 and SP3D3? Here the sum of the total number of electrons in the valence orbit of the each atom or ion. If total number is greater than 8 divided by 8, total number is 8 or less than 8, it is divided by 2. If the answer is 2, 3, 4, 5, 6, 7, then hybridization is follows. Here for total 2, hybridization is sp3, sp2, 4, sp3, 5, sp3d. It means here suppose 2 means s orbital and the p orbitals are hybridized. Here one s and 2 p orbital hybridized. For total 4, 1 s and 3 p orbitals are hybridized. For 5, 1 s, 3 p and 1 d orbital hybridized. For 6, 1 s, 3 p and 2 d orbitals are hybridized. And 7 is here 1 s, 3 p and 3 d orbitals are hybridized, and the hybridization is sp3d3. Now let's see the example for carbonate 2 minus. First of all, sum of the total of electron in the valence orbital of at each atom or ion. Suppose here it is carbonate ion, is called carbonate ion. Here the carbon atoms and its atomic number is 6. Electronic configuration 1s2, 2s2 and 2p2. So here in valence orbital there are 2 plus 2, 4 electrons, while in case of oxygen its atomic number is 8. Electronic configuration 1s2, 2s2 and 2p4. That means in valence orbital there are 2 plus 4, 6 electrons. Now total number of electrons is here for carbon its atom is only 1 and the number of electron in the valence orbit is 4 plus 3 of oxygen, 3 atom of oxygen, and the number of electrons are 6. 2 minus that means here it loses, or sorry, it gains of 2 electrons, so we need to add 2 electrons. Total 4 plus 18 plus 2 means 24 electrons. Means here it is higher than 8 electrons. So here if the total is greater than 8, then divided by 8. Here our answer is 24 electron, so we need to divide it by 8. It is 3. Means here sp2 hybridization takes place, because here 3 means one s and two p orbital, two p orbitals are hybridized. So our in carbonate ion there is sp2 hybridization. Okay, now let's see about the type of hybridization. Another example, in ammonium ion. Okay, for nitrogen its atomic number is 7, electronic configuration 1s2, 2s2 and 2p3. So here in valence orbital there are 2 plus 3 5 electrons. Okay, and the hydrogen 1s 1 and is plus. So total number of electrons here, nitrogen is only one atom, 4 of hydrogen, and here the plus, that means it loses of one electron. So in nitrogen atom there are 5 electrons, here 1 and minus 1 electron. 5 plus 4 9, 9 minus 1 8 electrons. Here the another conditions, if total is 8 or less than 8 then divided by 2. So we need to divide it by 2, that means here the 4 means here total is 4, so hybridization is sp3 type hybridization. It is sp3 type. So you can easily say which type of hybridization is takes place in particular ion or atom. In the last example for SF6 sulfur hexafluoride, which type of hybridization? For sulfur its atomic number is 16, electronic configuration neon 3s2 3p4, that means here 2 plus 4 6 electron in the valence orbital. And for fluorine its atomic number is 9, 1s2 2s2 2p5. So here 2 plus 5 total 7 electron in the valence orbital. For sulfur SF6 S plus 6F, for S there are 6 electron, and here for fluorine 7 electrons. So 6 plus 42 48 electrons. So it is greater than 8, we need to divide it by 8, that means here our answer will be 6. And according to the total of 6, it's our hybridization is sp3 d2 hybridization. Okay, so here from this table we can easily determine the hybridization. Okay, next time we will discuss another topic. Thank you very much.